Okay, thank you very much. We are going to proceed with our first panel of the day. So, Christina, go ahead and do the introductions, please.
So next up, we have our first of two Innovation for the Grid panels, which will present and discuss grid solutions that are enhancing the electricity system and the customer experience through technology and innovation. Much similar format as yesterday. Today, our panelists include Ty Roberts from Itron, Brian Bowen from FirstFuel Software, and Pablo Barrague from AES Energy Storage. Ty, do you want to get things started?
Yes, absolutely. Good morning, everyone. We're on? Great. Let me do a quick test here. Perfect. Got it. So I was excited at the opportunity to speak with you commissioners today on the topic of innovation, because there's one very clear trend that we've recognized at Itron that we're pursuing and investing a fair amount in at this point, and have really steered our company's mission statement around, which is the topic of distributed intelligence. What we've seen globally and across industries with the explosion of the Internet of Things, to use the buzzword, and a lot of this Jeff was really alluding to in the previous presentation about all the smart devices that are now existing in the hands of people, attached to devices that previously weren't smart. There's a lot more connectivity, there's a lot more computing power everywhere in the world today that we touch and we feel and we have and is around us. What that's creating for us is a really significant difference between the rate, the amount of data being created and generated by devices that has information useful and relevant to what we do every day, and the amount of value that we're extracting from that information. So these statistics here, I'm going to share a few with you, which I think are really key and highlight the challenge and the opportunity that we collectively have, are from the IDC Digital Universe study from a few years ago already. But the other studies have shown similar, if not larger numbers, more impressive numbers. From a data creation perspective, so this is data that's being generated by us or on our behalf by devices, is expected to grow by 50 times between 2010 and 2020. What that translates into from a per person perspective is by 2020, 1.7 megabytes of data created for every person every second, which is an amazing statistic and boggles the mind. Where this comes from is all of the different devices that we're using every day, from our smartphones, which everyone's aware of, and on that smartphone there's obviously lots of applications that are producing different data. Your Fitbit, just by walking around. Cars are becoming increasingly connected and capturing and creating a tremendous amount of information. Appliances in people's homes are getting smarter. Devices in your neighborhood that are tracking sort of sounds or looking for gas emissions, et cetera. So from a neighborhood perspective, that are gathering information about all of us, is exploding. 40% of all of that data that's going to be generated by 2020 will be machine generated, so not created by people, but passively collected and created by machines, devices all around us. Whether we're doing something actively or not, that data will be created. And amazingly, and this is true today, is only 0.5% of all of that data is actually used by an analytic function to create some sort of benefit for us. So there's piles, if you can imagine it, of data sitting in various devices or in large data centers and cloud back offices, for example, all around the world, that's really existing, and that's it, not creating any value for the consumer or for anyone. So what that creates for us is a tremendous opportunity, which we see directly in the utility space as well. So looking at the smart meter, for example, as a perfect corollary for this concept and for this challenge and this opportunity. So a smart meter today, first of all, itself, the fact that if it's gathering for a single consumer, for example, hourly load profile or interval data, that's an amazing step up from a single read per month, which is where you're coming from a pre-smart meter environment to a smart meter environment. That itself is a tremendous increase in the amount of information that we're gathering about ourselves, all of us. That device, however, that smart meter, is actually recording a lot more information or measuring a lot more information than even just that. So a typical smart meter today is taking about 16 measurements per second on average. Usually this information, this data isn't stored anywhere. It's being used to increment counters inside the meter, which eventually roll up to these load profile, these interval data streams. And that's the only information that's really being stored. But when you look at what that means over time, 16 measurements per second by an individual meter, that's 810 per minute. That's 57,000 per hour, rather, and then 1.3 million per day. So this is a lot of measurements. It's an amazing amount of measurements that are being taken in these devices that are on people's homes today. And again, all of that rolls up typically into a usable data space of about 24 values per day that's being collected, maybe, by utility and used. So there's a lot of capability in that just the metering device that could be put to a lot more use than it is now. So this is where we're really focusing our efforts from an innovation perspective. So where we see this going is taking that smart meter and turning it more into, from just a pure meter to cash, let's get the bill out the door device, which is what it's being used for today. And let's use it for what it really is, which is a computer. So a smart meter, a current generation smart meter today, and this is not just Itron, this is generally everybody, has about the computing capability of an early generation smartphone. So it really is, it has an advanced processor, it has data storage capabilities, and this is sitting on the side of everyone's house today, and the utility, this is an asset that utilities own and are able to manage. What our vision is, and what our view is let's try to harness all of this capability of data creation that these devices have today and create applications that can use that locally, just like you have with a smartphone. So on that computer, our objectives and our strategy is to create a software environment that you can download applications to that allows the utility to create value from these 1.3 million measurements that are being taken every day that are being thrown away by a large part. So I'm going to show a quick video, and I apologize in advance. This is a marketing device for Itron. It says how wonderful we are in a point or two. I want you to not worry too much about that piece. Focus more on what the capability that it's illustrating, and I'll talk a bit about it when it's done.
OpenWay Riva helps utilities avoid new generation costs and improves system reliability by increasing the effectiveness of demand response programs. With OpenWay Riva's intelligent demand response application, the total demand reduction requirement is calculated as an average reduction per meter. Meters assigned to a demand response program are allocated to smaller, local groups based on customer profiles and load characteristics. When a demand response event is initiated, each group is asked to achieve the required reduction based on each customer's ability to contribute at that time. Meters within each group then communicate and collaborate locally to control loads to ensure their target reduction is achieved. Only OpenWay Riva can ensure the overall required program reductions are met, even though reductions may vary from meter to meter. During the event, one spokesman meter from each group communicates results back to the utility regularly, optimizing network resources for timely performance evaluation. With OpenWay Riva, demand response results are predictable, reliable, and measurable.
So what's happening here in this case is a typical demand response program is using predictive analytics in using data models and statistical models to predict what individual consumers are using, what level of curtailment or load shedding they could accomplish each themselves, and asking very broadly everyone to reduce load or to send messages, signals to devices to reduce load. The challenge with that is what if today is not a normal day? What if the device that you're asking to shed load is actually not on because the people aren't home? One of the advantages of using the devices, the meters in the field are actually taking these measures is they know what's being produced in the home at this point. And they can even know what kinds of devices through analysis are being used by looking at this 1 second data that they're measuring continuously. They can tell what's on in the home. So they can more intelligently say, I have load to shed, I'm going to turn this device off because I can, and it's going to give us a savings of X. You can have pools of devices that are communicating to one another in the field, like in this example, where they can share, I've got load I can shed, I don't. I've got storage that I could turn on and push out to the grid, for example, is another use case that you can enable here. You can turn things on and off in order to achieve a much more targeted, much more balanced result and achieve the ends much more accurately and reliably. That's the concept that we're looking at leveraging within Itron, is pushing that intelligence down to the devices using the data that they're already measuring today to make these decisions. A few other examples I want to highlight for you guys before ceding the floor are outlined here. So, in particularly focusing on innovations that are targeted towards consumer benefit. There's a number of applications that we've been working on, and we see high impedance detection is a fantastic one from a safety perspective. So this is cases where you have a meter in its socket that hasn't been clamped in perhaps completely properly, or there's some issues with the wiring to that meter socket such that there's a bad connection between the meter and the actual wiring into the home. What can happen over time is that generates heat, which can then further erode or exacerbate the problem. That heat generation obviously is a problem. The way we've tried to address this in the past is by putting temperature sensors in the devices themselves, but there's a couple of problems with that. One is it generates a lot of false positives, and the other is it's not really measurable until you're almost too late, you're too far down the road. If we have algorithms inside the meters looking at this 1 second data, checking for impedance that may be growing over time, you can actually catch these cases before they become a problem. So what you're preventing here is, in the worst case, is fires starting within the home or a meter actually flying off of its socket if it gets to that point. These are real safety issues that happen in the world today that you can prevent if you're looking at the information, the data that the devices are already measuring themselves in the field today. Broken neutral detection is a similar case where this is where so wiring lines into homes have two hot lines of 120 volt each. There's also a neutral line that goes carries amperage back to the transformer. And that does a couple of things. One is it balances the load within the home so that you've got all of your appliances and lighting are using the right level of voltage. It also ensures that there's a place for that amperage to return to safely. If you have a broken neutral line, which can happen in cases, especially in new constructions or in new subdivisions, for example, where there's construction happening, there can be lines severed by accident, by digging. There can also just be, as you're putting up things quickly, these can happen. Over time, these lines can erode as well. Today, when consumers see a broken neutral, they'll see flickering of their lights in home, or they'll see one light brighter than the other, or certain devices may not be working properly. By that point, the problem's already pretty far advanced. What they need to do then is recognize that this is a wiring problem. I need to call the utility to come and fix it. With the same sort of algorithms and logic within the meter itself, we can detect these cases by looking again at this 1 second data that's being generated. We can detect these cases before they become safety issues, because more than just causing irregularities in your lighting, these can cause outlets to short out or even again cause fire damage. So this is another safety case that you can now address because you've got the data in the device itself to find the problem and to report it accurately. One more I'll highlight here before I step away is load disaggregation. This one's interesting because, and I raise this intentionally because there's always a concern about privacy. And this is information that the device is recording. It's information that the consumer absolutely owns because it's about their habits, their use of the electricity. And yes, you can tell what's happening in the home at any given point in time. From these services, we believe, add value, create value for the consumer. They should be treated as opt-in type programs. They should be optional services that the consumer agrees to take. Load disaggregation is one such that we've been talking to a number of utilities in Australia, for example, where it's a fully deregulated environment. There are retail service providers who are looking for value-add services to provide into the home. They see load disaggregation as a key service that they can offer as a service on itself, but also to enable other ones. So this is using, again, these measurements that the meter is capable of taking already today to determine what type of load is being consumed in the home, what devices are on, what are off, so that if someone's on vacation or they've gone to work and their stove is still on, they can tell that that's happening. The meter can tell them that, and they can turn it off. Another example of where this is useful is we've seen utilities or retailers rather who've looked to offer a service for seniors to track what their normal traditional habits are on a day-to-day basis. And if their patterns of use become irregular, that could be a sign that there might be something wrong with them. They've fallen, they've gotten sick. You can have a caregiver come and check on them. You can have a family member come and check on them. There's many uses for this kind of a service. So all of these are now capable using this data that we traditionally haven't been able to store, number one, or take back into a data center in the back office. The last slide I want to leave you guys with, because I know Brian is coming up next, is what I don't want to give any impression is that data analytics, big data processing, analytics in the back office is no longer necessary or valuable. That's absolutely not the case. I think the point from an Itron perspective and where we see this innovation being key is that this rate of data creation of devices in the field is absolutely outstripping our ability to take it back into a back office and use it. So we want to be able to use data wherever it's most useful, whether that's in the field, at the edge of itself, in the device, or in the back office to create value for everybody. I'll pause at that point. Thank you.
Ty, thank you very much. We'll continue our practice of holding questions until the panel has had the opportunity to present in full. And Christina, we've got Brian coming up next. Okay.
First of all, thank you, Chairman Hawk and commissioners, for the opportunity to be here today and for initiating this proceeding. It's a very important proceeding, and you can tell by the attendance and the interest today that many believe so. Well, I think Ty really set up beautifully this next topic, which is looking at analytics, and I'll be speaking specifically about improving the consumer experience, but also grid performance through the types of advanced analytics that can happen for business customers today, so commercial and industrial customers. So one of the things we see at FirstFuel by working with about 35 utilities in the US, Canada, and overseas in Europe is personalization is really one of the keys to the future energy universe we will live in. And when we talk about personalization, we talk about things like you're seeing in the center of this slide. In the same way that when you log in to pay your credit card bill and you can see how much you spent on airfare, on paying your mortgage, or what have you, each month, we're able to, through a similar process that Ty described, disaggregate a customer's energy consumption into end uses like heating and cooling, refrigeration, pumps and motors, and several other end uses for commercial consumers. And the goal of doing this is to have a better informed consumer who is able to make informed decisions about the array of energy options that they have today. And personalization, as we all know, is not a new concept. It's something that is being utilized in a number of different industry segments. The Netflixes, Amazons, Ubers, and Targets of the world, who are often name-checked in grid modernization proceedings, they've done an excellent job taking data about the consumer and having them have a more personalized experience, whether it's buying the right type of laundry detergent when you're at Target, or being able to automatically pay for a service like Uber without having to enter your credit card details. It's a seamless, easy experience. And utilities have taken notice of this. We've got two quotes here, one from the CEO of PECO a few years back, saying that consumers are expecting the same level of service that they see from other service providers at the utility. And at Southern Company, a recognition within the industry that there is all this data about customers, but there's an opportunity to use it to learn more about customers, and utilities can do that. Now, why has the utility industry not focused on personalization to date? I think, Dr. Taft in his comments this morning described, the idea was to keep the lights on. A personalized service was not really a priority at that point. It was more about reliability and affordability for customers. In addition to that, regulatory incentives have favored capital assets, less information technology, and things like that Amazon and Uber have certainly invested in to build their businesses. Now, of course, we're all here today because things are changing. There's a wedge being driven into this process where distributed energy resources, the increasing availability of data, as Ty described, and policy ambitions and policy initiatives are really changing the conversation from a single commodity for every consumer to a variety of energy services that perhaps live on a platform, a grid platform. And to speak specifically to the data aspects, I thought Ty spoke to this beautifully, but from December 2007 to the present day, we've seen an order of magnitude increase just in smart meters. And as Ty described, the data that is coming off these meters is many orders of magnitude above that in terms of data points per day, per hour, and even per second. And what we see from industry sources like the Institute for Electric Innovation, smart meters are really becoming the new business as usual. So if we have all this information, then what are we doing with it? From policy perspective, I'm coming here from Chicago today, and Illinois, as you may know, recently passed a large energy bill, the Future Energy Jobs Bill, at the end of last year. And one of the components of that bill is that electric utilities shall incorporate advanced metering infrastructure data into the design, the planning, the implementation, and the evaluation of energy efficiency programs. And that's a policy goal that the General Assembly had decided was important, something that was included in that bill, and it will become effective in just a matter of weeks. So these are the types of initiatives we're seeing that are taking this data that is now available and turning it into policy actions and outcomes for consumers. So what have we as FirstFuel learned in working with 30+ utilities on these types of initiatives? Well, to build a consumer-friendly smart grid, we really need to have energy data be accessible and usable by humans, not just machines. The machine, the great machine we built, the grid, obviously is processing much more data than any one of us could as a lowly human being. But when it comes to the customer experience, we need to translate all of this amazing information into things that people can actually act on. Secondly, to engage customers, utilities really need an incentive to do that, and I think that's one of the reasons we are here today discussing that. I think the incentives should also come from policy goals. If something like energy efficiency or distributed energy resources or a cleaner power source are important, those are the types of policy goals that should be supported by customer engagement. It should not be engagement for engagement's sake. And then finally, as we know, technology will continue changing. So the importance of customer engagement should be to educate customers on the new offerings that inevitably will come along, be they things like storage, rooftop solar, the ever-changing array of energy efficiency options that customers have. We should count on those to change over time, and so how can we keep customers informed? And I'll provide a few examples about this. But again, just to refocus us, so FirstFuel is really focused on business customers. We don't work with residential customers. And the reason we've done that is because they really represent the lion's share of energy consumption on the grid. And so that means they're systemically important to the grid. Of course, residential consumers are too, but any given commercial customer can have an outsized impact through the decisions that they make. And what we see from reports from Accenture and other parties is there's a great desire for personalization in the commercial sector. And that is because a corner grocery store is not like a pizza parlor, is not like a nail salon, is not like a Walmart. Each of these users has different energy consuming needs and different preferences. And so our building engineers have come up with more than 130 business types that we're assigning to any given customer when we work with the utility to create that personalized experience. So what do we do when we're using this data and we're working with the utility? Well, at the bottom of the slide here, you're seeing different channels of customer engagement as we would define them. So there's the digital experience, when you log in, as I said, to pay your bill, and you're able to see, 60% of my bill went to cooling this month. and it was particularly hot outside, and now I understand why my bill was higher. It could be a conversation with an account manager. For a large commercial account, there are usually assigned account managers at utilities. They're able to have better informed discussions with their customers. For the smaller accounts who are not assigned, it could be a call center rep. And we certainly know that not every customer is going to be using a smartphone app or logging in online. So having informed customer service people when someone picks up the phone, that's obviously a very important part of the equation. And then finally, marketing or outbound communications from the utility could be everything from an outage alert to a new program promotion, making sure that those are personalized to that particular business customer. And at the top of the slide, you're seeing a few of the things we can do with data. So I've already talked about improving data display, notifications if you're using more energy than you expect, improving data access or the ability to download through Green Button Connect. And then finally, for jurisdictions where there are building benchmarking ordinances, collecting data to report that is challenging for many consumers. So how can we improve that through software tools? These are the things that we're working on. So just to speak to the digital experience again, we want to make sure that customers understand the ways they're using energy, but can also act on those things. So what you're seeing at the bottom of the slide here is a specific recommendation for this customer based on their load profile. By installing lighting controls, they'll be able to save a certain number of dollars per year. There's carbon savings and an expected payback period also tied into that. Based on that customer's meter data, this is something that they would log in and be able to see for themselves. And of course, a big blue button, I'll do this, which would connect them to someone to provide that service, either at the utility or through another party. Of course, this is something they opt into and have their option to participate. So now I want to speak to the grid aspects of this. I've spent a lot of time on the individual consumer and their experience. How can we take these individual insights and roll them up to the grid level? Well, as I mentioned, commercial customers have a lot of demand on the system. And so in this project for PG&E, our goal by doing data analysis for them was to identify opportunities to permanently reduce customers' peak demand. And the reason we were doing this is that PG&E had identified a number of substations that within the next few years would need to be upgraded. As you know, these are millions of dollars of investment that would go into a substation upgrade. So the idea was to find enough customers with enough permanent peak demand reduction potential to offset the need to invest in that substation. And we were able to do that at a number of different substations for PG&E and also predict which customers would be likely to opt in. You obviously need more capacity than you think consumers will actually agree to, because it's requiring an action on the consumer's part. And so by identifying this potential, they were able to offset that investment and delay it a few years out. And this is something that benefited not just the customers that participated in the program and saved on their bills each year, but also every other consumer who didn't participate, because they've now been able to delay that substation investment, and that's something that finds its way into their lower rates over time. Another example here, the connection between the consumer and the grid often is what they pay. So if we talk about different rate plans that are offered to consumers, through smart metering, we're able to offer much more advanced rate designs and rate options for small commercial customers who may not have been exposed to them before, all the way up to large consumers as well. And so, again, an example here from PG&E that has dozens of different rate options, especially for customers that have net metered rates, time of use, time varying rates, with peak adders and things like that. So it's a dizzying array of options for the consumer. How can they be sure that they're picking the right one? Well, we've created a tool that looks at the customer's past energy consumption, could be a year or 2 years previous, looks at the weather impact of the way that they're using energy, looks at the devices that we're assuming through our algorithms that they have in their facility, and we're able to provide them the optimal rate based on the way that they use energy to save on their bill. And we can also provide what-if analysis. So if they were to do a lighting upgrade and switch to a different rate design, how would that impact their bill? And I think something like this is important not just to the individual consumer, but to the grid at large, because we do want to see customers opting into these programs. They have grid benefits, and we need to take some of the risk out of the equation for them to feel confident in making that decision to move forward. And a final slide here, not the most visually interesting, but this is a matrix meant to represent how the interaction of those two things, different energy options, be they things like battery storage and PV, which are distributed energy resources installed at the consumer site, or changing out different energy consuming assets, how those interact with the rate option that the customer chooses. And what you're seeing in this matrix is, there is a great amount of interaction in terms of the amount of savings the customer will see based on the rate that they choose and the energy consuming option that they choose. So part of our goal in working at the grid level at FirstFuel is to kind of orchestrate and optimize the rollout of distributed energy resources as well as energy efficiency options for the customer. And you're really able to do that now thanks to the great availability of data and customers' clear interest in having a personalized way to consume and use energy. So I'll leave my comments there and look forward to questions and Pablo's remarks as well. So thank you very much.
Morning. Can you hear me? Can you hear me well?
Yep.
I want to thank you all for this opportunity and congratulate the Commission and the staff in this initiative. It's really, really important. And I actually want to thank, excuse me, who built the schedule for today. It makes my presentation a lot easier. Much of the landscape, it's already laid out on the previous presentations in much more depth than I would have done it. So quickly, and this is important because of the company's mission. AES Corporation is a Fortune 200 company built on the trail of deregulation across the world in the 80s that quickly expanded to several countries. Today we operate in generation and distribution areas in several countries. And our mission is to improve lives by providing safe, reliable, and sustainable energy in the markets we act. How do we do that in this ever-changing grid? So this is the part that I guess Jeff's presentation makes my explanation very easy. I don't have to go over this, but this is basically what he spent almost an hour explaining to us, and he still left us with many questions. But you might have heard this before. Until a few years ago, if Thomas Edison could come and take a look at the grid, he would take a few seconds for him to understand what was going on. Today, it would be a little harder for him to start questioning what is that and what is this on the grid and what is this doing. And in a few years, you'll probably don't understand anything that's going on the grid. And many people say that the revolution we're seeing in energy is similar to the disruptions that we saw in telecommunications in the 90s. And it makes total sense because, as you saw previous presentations today, you needed the telecommunications to enable this transformation in energy too. So AES has been doing energy storage for almost 10 years now because it understood that that would be one of the missing links of this transformation, the way that energy is consumed in different ways now and is produced in different places, and mixing new types of generation with now distributed energy and this complexity, having this sponge type devices that can absorb energy and release energy when mostly needed or when mostly valuable to the grid. It would be of imperative importance. That's why they invested so much since 2007, 2008 in building this fleet of energy storage across the world. This is to show that energy storage is not new, it's not the future, it's already here. Just AES alone has over 400 megawatts of energy storage grid scale facilities operating or being built or already contracted. in almost 20 locations in several different countries. So again, as we talk today, our priorities for the power system are the reliability first, lately lower cost possible, and also lately having clean energy, having that energy to be clean. And the challenges behind that we're facing today is that efficiency in the grid, integrating these renewables that come with their intermittency and at different parts of the grid, and the aging infrastructure that was mentioned today as well. Most of our infrastructure, electrical infrastructure, was built several decades ago, and it's coming to an end of life almost altogether. So how does this look? This is just to illustrate how, so it's not conceptual, it's actually how a grid scale battery system works. This is an architecture that we developed. It's very, very simple, and that's the whole idea of being very simple. You can see the cells, or could be prismatic like the ones in the picture on the left, could be cells compared to the batteries, the same format as the batteries that we use in consumer electronics. They are bundled into these packs, then into these trays, and then when you see in the middle of the picture, they're integrated in what we call a node. It's on a rack that has the power converter system between AC and DC current, and the software, the computer, the battery management controls, battery management system and controls of the battery management. This is important because it's the least smallest unit of a system that you can have. So this is around 100 kilowatts, makes it scalable. You have 100 kilowatts that can be operated independently, and you can scale that to megawatt sizes, 100 megawatts. So you just put them together like the picture on the right. And the picture on the right explains a little bit. Internally, we have this joke. The people that started this at AES and they're still working and leading the energy storage team, they come from a background of IT and telecom. So when you ask an IT guy to build a power plant, they come out with something that looks like a server farm. And it's exactly how they look and they feel when you go inside of one of these facilities. They're very simple, very easy to visually to understand. And redundancy is the main thing behind this idea. The availability of these architectures, it's very, very high. That's what adds to reliability and resiliency that we were talking today. So this is a little bit crowded slide. I'm not gonna explain each of these parts, but it's just to explain that energy storage plays a role in all different parts of the electric system, in generation, in transmission, in distribution, in commercial and industrial, even in residential, as many of us have seen lately in the news. And I'm just gonna focus on a few so you can understand this better. This is one of the main challenges that California is suffering or facing, better said. If you haven't heard, most of you, I assume, have heard about the duck curve caused in California, basically because of solar penetration and distributed solar penetration. That creates that the belly of the duck that you see in the middle of the day. So there is an over-generation during the day that stresses the grid a lot, because when the sun comes down, usually coincides with the peak. And the ramping needs are extremely challenging for the grid. You see, they calculate today that in a few years it's going to be around 13,000 megawatts that need to be ramped in a few hours. That makes it very, very challenging to keep the lights on, right? So a couple of years ago, this was in 2014, that Southern California Edison had an open procurement for peaking capacity. They had planning and they had a program, they had retiring units, and they wanted to have peaking capacity by 2020. this open bid was really interesting because the batteries entered in a bid with 1,400 different proposals. Thermal was openly bid there too. And battery won. We were awarded 100 megawatts. That's the rendering of the building that's contracted. We're going to be building in a couple of years. This was really interesting to debunk a myth of, well, energy storage is expensive. Well, back in 2014, it was already being contracted at 100 megawatt size. And why is that? How to explain this? This is substituting a gas peaker in California. So one thing that they understood is the flexibility that energy storage brings, and that flexibility had to be valued. Because it can discharge when needed, but it can also charge, you have much more flexibility than a power plant that has a minimal optimal point of operation and then has a much smaller, would be the same size of plant in megawatts, but a much smaller range to operate. And they did, this is just an illustration of how do they compare apples to apples. They understood they couldn't just compare the energy storage initial upfront cost with a gas peaker upfront cost. They needed to see all the benefits that energy storage brings to the system and to the grid. And on this waterfall type of chart represents in a very easy way, their complex models to understand all these benefits that it's bringing to the grid. And you reach the effective cost of the energy storage system. You compare apples to apples, and it's much more economic. It makes the whole grid operate in a much more optimized way, something that's increasingly harder for the actual grid to do because of all the transformations that we've been seeing. That's very costly for the existing infrastructure and the existing generation to be changing, ramping up and ramping down all the time. So most recently, this is to show that everything or anything that you heard about energy storage, I would say a year ago, maybe 6 months ago, I would consider it ancient history. It changed so much in the last months that we had to keep doing this type of events and keep revising so we can learn from different applications of energy storage in different parts. This was deployed a couple of months ago. It's the world's largest energy storage system, 30 megawatts. It has a 4-hour duration. It was an emergency procurement that Southern California investor-owned utilities put out. They had a gas storage facility that was shut down, and they needed quickly capacity. And they were used to look at energy storage. They were comfortable about evaluating it. They were confident that they know that it works. And they did this procurement between contracting and actually putting them online. It took no more than 6 months. 6 months to put a facility like this online in California with all the anywhere it would be a challenge, but in California with the permitting challenges, it's a great achievement for the electric industry as a whole. You can see how dense it is, where it's located. How it would make it even more complex to do that. I have a short video where you can see how this was built. It's a time lapse created by the owner of the system now. So see, these are the foundations, and this is what we call a containerized solution. Other pictures that you saw was on a building solution. This is for different reasons because of siting. This was done in containers. It doesn't matter. There's pros and cons on each one, and you can interchange them. And these are the containers with the batteries in there. Up on top of the containers is the air conditioning systems. And this is how this was built in a handful of months in San Diego area. So what is energy storage and energy storage helping, and what energy storage can help? This is very simple, or it might be a boring graph, but I'll try and make it really simple. On the left, this is utility asset utilization, right? How many hours of the year you're actually using those transmission distribution assets, meaning a few hours of the year that you need to have it overbuilt for reliability to keep the lights on. But if you could just, instead of building a new substation, just put some batteries, one of those containers at that substation distribution level, and not have to upgrade or build a new substation for several years, because you're only meeting those few hours, a few months of the year, until you have certainty of that load growth. That's another challenge that is getting increasingly challenging, that planning for load growth. So on the right, you can see it's just a depiction of you have to make big investments at once in bulk with all this load growth uncertainty. And the blue line, you can see how you can just build the right size that you need, the right location that you need, with much more certainty, and that produces, obviously, lots of savings. This is another system that came out. It's online since this year as well. Another big achievement. This is at APS in Arizona. It's a solar partner program where they have 1,600 utility-owned solar, rooftop solar residences with smart meters. And that obviously has, because they are all concentrated, and that's how solar rooftop spreads, because it's very much word of mouth, and the neighbor did it, he showed his savings. Oh, I want to do that in my house too. That's how even the companies sell these systems. And then you have a lot of concentrated, small, tiny, little duck curves in these pockets. So this is at the feeder level. There's two of these systems at APS Grid connected at the feeder level. One is at the substation. The other it's in the middle of the feeder in a different location to a different pocket. And they are helping integrate those renewables, those solar rooftop that's coming from those houses and from those communities. This is just a simple depiction of those feeder levels, the thick blue line, and the distributed, those are let's say, the neighborhood and houses. And this is providing 4-quadrant injecting reactive and real power to whenever it's needed, and balancing that localized system connected at 12.47 kV. So we see, I'm coming this to an end, so we have time for questions for everyone. We see this as energy storage as unlocking this full potential of this overbuild that we have. Everything more and more being electrified, more consumer electronics, vehicles being electrified, renewables coming in large scale. They are ready to reach cost parity in so many places, and they're coming in so much large volumes, also in a distributed way, not just in utility scale. And energy storage coming in to transform the grid and help integrate all these challenges. What it actually does, it's might seem obvious, but it unbundles the couple supply and demand. It makes it a lot easier to manage all these challenges on the grid when you have this buffer holding for anything that's coming our way. this is not a Photoshop. This is a real picture of one of our energy storage facilities. It's on all of them. It's inside of the building sometimes. It's outside of the building. So again, thank you for the opportunity. And
Thank you, Pablo. Okay, so let me ask the first question of our panelists. So, akin to when we heard from panelists yesterday that were typically behind the meter, customer focused panelists, really the question became, of course, we, at least from my lens, I won't speak for the other commissioners, we love what you have to offer, okay? And so, we roundabout got to this yesterday, but talk to us a little bit about your access to the grid, success stories and barriers associated with access to the grid for Riva, for Brian, what you guys are implementing with CNI customers, and Pablo with storage. So I don't know who'd like to start.
I'll take a swing at it. So in terms of our access to the grid, I mean, we are working with customer meter data primarily, and we work with utilities as an agent of the utility in the same way that a billing provider would in looking at that data. I think the more innovative things that I spoke about a bit in my presentation that relate to the grid, things like non-wires alternatives projects, you hear that term quite a bit, where we're able to look into customers' meter data, understand the assets that are being utilized at the customer site, and how those relate to the need potentially to invest in the grid in the future, and how that could be put off for a few years. And so I think that's really the most exciting opportunity that we see is taking this individual insight that any given utility could have, thanks to companies like Ties that have done an amazing job creating this data. And now the challenge is how to utilize it, not just at the individual customer level, but at a grid level. So I think, that's what we're most excited about. I think it's the next stage of the smart grid is making that connection between individuals and the grid at large.
And do you use utility interchangeable? Because on your slide that listed, I think, some of your partnerships, I think you had some competitive retailers that were on your slide as well. Do you use those interchangeably? The concept of utility and retailer?
So in retail markets, say in the UK, where we're working with E.ON, they have about 400,000 customers in the UK, and their aims and needs may be a bit different than an investor-owned utility or a municipal utility here in the US. Ty spoke a bit about this as well. Retailers are interested in services beyond the commodity itself, oftentimes. So we're helping them, again, understand whether it's an audit that a customer needs or retro-commissioning measures that the customer could have installed. Those would be the different types of services that could be offered in a retail market. But there are many investor-owned utilities who have, say, energy efficiency goals. They need to reach them. They want to reach them at the lowest cost because that's going to benefit all consumers. And so having a deeper understanding of the opportunities that are out there to save energy to meet those goals, that's important in the IOU market as well.
Okay, thank you.
I'll take a slightly different swing at that as well from the Itron perspective. So I had the opportunity to work in Europe the last 2 years with a very different regulatory environment. So I think I have a much greater appreciation for the role that policy plays in fostering or frankly stifling innovation. So in Europe, the focus has been very much on, because their policy it can be 15 years old in terms of EU mandates for deploying smart meters. The way the business cases were established 10, 15 years ago were very much focused on automating the collection of data, reducing operational costs for the utility for collecting that data, and those were the business cases. And frankly, in Europe in particular, where there's the average load per home is not nearly what it is in the United States and in North America in general. Their business cases are very, very stringent, very tight, and they're not. Utilities in Europe are really not incented or able to take advantage of innovation like we've been talking about this morning. it's very refreshing to come back to the U.S. And see it's an entirely different policy climate here. I think that's something that I hope we continue towards. I think the investments that we talk about from a smart metering perspective for utilities are already very significant. I think what I'd want to highlight is that it's a significant investment. As we've talked about this morning, there's lots of capability innate in those devices, in those solutions, those systems, those platforms that are being deployed as part of it. I think ensuring that utilities have the ability to, and are incented to unlock some of those additional beyond just the just reading of meters automatically and collecting of data every day for ostensibly for billing purposes is allowing the creation of this data that's being produced and this information that's being gathered and analyzed wherever that may be to provide additional benefits to consumers is allowing that to happen. I think that's where I've seen outside of the U.S. in particular, sort of a stifling effect on that. So I think just being mindful of the technology that it's available today, there's a lot more use that it can provide to the consumer, to the utility, and to different players in the market beyond what it maybe its intended purpose is, and let's make sure that there's ways to unlock that over time.
Thank you. Pablo?
Sorry, can you repeat the original
So
question?
it's barriers to, you've shown us some success stories for sure, but in trying to deploy the AES storage product and trying to integrate that product into the grid, what are some barriers that you've faced that we should be conscious of as we move forward?
We see that it's important to have it on the planning. If you see that there are some PUCs in the U.S. already directing their utilities with policy statements telling them they have to have prudence when they evaluate the alternatives. They should not just look at the traditional. Like I showed today, things change very fast, 6 months, a year. Use very current data, right data, to evaluate the alternatives for any traditional solution, and as well evaluate the cost in a cost-benefit analysis, like I showed in that type of waterfall graph that depicts the result of this. Those are we see as the main let's say challenges when you understand exactly what is the real cost. And in a cost benefits analysis, you see the real benefits. You can then compare apples to apples.
Okay, and I'm very sorry if you already covered this in your presentation, but can you just give a very, very quick 1 minute on the AES storage business model? Are you working with utilities to try and have the costs associated with storage be recovered from the rate base, or are you competitively bidding something storage oriented into a marketplace? I'm just need a little bit of education there.
Yes, we started putting these systems in our own platform.
Yep.
It evolved as something that many utilities were interested. We started to sell them to other companies, and in different parts of the world. So there are even other countries that are already rate-basing energy storage because it could do substation deferral, and there's generation alternatives is in open source, all source biddings that we could show that if correctly evaluated, energy storage can win. And what ties all this is the possibility to energy storage to be cost recovered, and at the same time so it doesn't sit idle, being utilized in wholesale markets doing other functions, as long as those revenues come back to reduce the cost of that asset.
Very good. Thank you. Thank you. Commissioner?
I have a question about costs, and I wanted to kind of direct it here, and then I have another question about storage and batteries. So can you give me a little bit of a sense of the cost of accessing the data to customers? I can sense that maybe in the long run, there's probably a definite advantage, and the cost decreased dramatically by the ability to utilize that information in terms of saving money. But I was just wondering, how does that look for customers? What does that profile look like as far as the costs associated with leveraging that data?
So from the, and I'll speak from the sort of the distributed perspective, the cost is actually very low. It's really based, and this sort of ties back to the point I made earlier, is that the investment that utilities are making in a smart metering system, for example, they're already buying a lot of the capabilities in terms of, a highly capable field area network that can facilitate communications and the collection of this information. The devices in the meter themselves it's already a computer when you're buying it. I think it's just making sure that you're buying solutions that are able to leverage all of that capability that's already innately in there. So from a distributed computing perspective, it's the cost is really embedded in the implementation of a smart metering solution to begin with. And then there's very small incremental costs to deploy applications on these different devices to actually create new value. But that's minimal in the grand scheme of the cost of putting in the solution in the first place, end to end.
I'd echo what Ty said. I mean, where FirstFuel comes in, a lot of the infrastructure has already been built, and so the incremental cost of adding essentially an application on top of that IT infrastructure is very, very low. One of the reasons that we are in business as a company is that the cost of computing has become very, very low as well. So for the analytics that we're doing on behalf of our utility partners, that's also become very affordable. And when we offer services to business customers, there's no additional cost to them to use those services. It's part of the standard offer that the utility has with their customer. So it's not any different than, again, if your bill is sent to you as paper or it's an e-bill, similar sort of standard offer to the consumer and something that builds on the infrastructure that's already there at a low incremental cost.
Great, thank you. Pablo, I had a question about batteries, particularly. I'm really interested in them. I have a personal, infatuation, if you will, because I visited the battery array outside of Dayton, and I kind of view batteries in a way, and correct me if I'm wrong, as sort of like the wireless phone has done for the telecommunication industry, where the future potential of batteries could also allow for places that don't have electrification to leverage that in some ways. And I know right now the storage that you have is in the midst of cities and other places, and it's near substations and whatnot. But can you talk a little bit about the future of batteries and energy storage and how that can, what that kind of looks like?
Well, we're still building it. We're already building it. We would like to see, and I think there's no way to reverse this, if you see projections and if you see any outlook of very respected research consulting, the size of this industry, especially lithium ion, because it builds on an industry that's much larger, that's consumer electronics and electric vehicles. It makes it's manufactured by really large companies with really large balance sheets. They can give performance guarantees, and it makes it bankable, right? It doesn't you don't get locked into one manufacturer or one technology, and you can always, it looks at the long term that you can have these systems for operating for 20 years. We see several applications for batteries. There is also applications like you were more in the way that you were mentioning, where you can even bundle it. They call it dispatchable solar. You can bundle energy storage with solar. That depends of particularities of a location of a specific place and requirements that a specific place might have for interconnection, or in their plans on their IRP, whether they plan for renewable, how much renewable they want to have. But we see it's not necessarily directly connected to renewables. Even if there were no renewables, batteries will still have a huge impact, bringing flexibility to the grid and making the grid work more in an optimal level. That's what saves money and reduces emissions.
Okay, thank you.
Tom.
Thank you. I wanted to talk about a little bit about what Dr. Taft said earlier about, probably in the 1900s, we would be looking at, 5 years, 10 years, and getting a pretty good idea of what was being spent, what we were getting out of it. And, I think that this is the most exciting time to be involved in the things that we're involved with right now. But when I look at smart meters, when I look at energy storage and energy data, I wonder about not only the cost, but also the shelf life. If we just wait 5 years, if we just wait 10 years, I mean, what more can we get? And what I wanted you to do is just talk about the shelf life. And is that a reason to delay purchases, or, because we're all talking about whether, most of us are talking, at least when we're talking about customers, is the priority of limited resources. And but I specifically want you to talk about the shelf life.
Yeah, it's a fantastic question. One we certainly appreciate the challenge of as well. I think it's when you look at the type of services and the type of capabilities the type of service you can offer from the technology that you're buying today, and think about it from sort of a competitive perspective, where the investments that are being made now from a smart metering perspective are using, at the heart of it, it's the meter that we're all familiar with, or at least think we're familiar with, but the historical sort of image of this device is an electromechanical thing that you stick in the wall and you leave it there for 20, 30, 40 years. The devices today, as I talked about, being computers, changes that pretty dramatically. So it's a much more sophisticated device. It's subject to Moore's law, in that we have continuous, rapid improvement in computing power, in storage power, in the types of services then that you can deliver upon that. I think the challenge is, if you wait and defer, this is a curve that's not at any point going to be decreasing or lessening. I think you could play that game with yourself for forever. I think the point is to jump in and start taking advantage of this, and start making, as a utility, being seen as a provider of services that are going to be provided by somebody eventually. I know that Dr. Taft mentioned Google, who everyone's always on everyone's mind, that if we don't do it, Google will do it. And I think there's absolutely some truth in that. There will be ways the people at large and society at large are expecting more and more information, more and more services to be provided to them as a matter of course. And if any sector, utility included, doesn't really step into that fray, then it will be provided by somebody else. That vacuum will be filled. So I think that's the risk of waiting, is from a competitive perspective, utilities will fall behind and be left with the hard job of keeping the lights on, of making sure that there's a balanced and sustainable and hardened grid without being able to take advantage of any of the other benefits of the investments that they really need to make today anyway. So I think that for me is the key. What that goes along with that is that this old mindset of this device that you stick on a wall needs to last for 20, 30 years needs to be rethought from my perspective as well, because there is an evolution, continuous evolution, in the capability of all of these technologies that we've been talking about. And I think you don't want to preclude yourselves from, as a utility industry perspective, none of us, from being able to take advantage of those, because that vacuum will be filled by somebody.
I think it's an excellent question as to the shelf life of any IT investment, and Ty illustrated it perfectly how things change so quickly today. One of the ways that we address it as a company, FirstFuel, we are a software as a service provider, and it's a term that, one of the biggest providers, it would be Salesforce.com, and in fact, for a while, their logo was software with a line through it, like crossing out software. And the idea is you don't install something on a CD-ROM or a DVD-ROM, or they all go out of date these days. You have cloud-based software that is constantly updated, constantly brought up with the latest specifications of the marketplace. And a company like ours, we offer that to utilities, and we offer it to dozens of utilities. So the benefit of that is if there's a new feature that someone like PG&E that I mentioned in my presentation several times wants FirstFuel to build for a specific purpose, it's highly likely that there will be other utilities out there that have similar needs, maybe this year, next year, or 5 years hence, and there won't be individual point solutions developed by every utility just to serve that unique need. There's a platform benefit. So I think that's one of the things that commissions all over the country are really starting to take into account. Many of you may be familiar with the NARUC resolution from this past fall, encouraging commissions to look at the accounting treatment of cloud-based software and software as a service. I think giving utilities a level playing field between building it themselves and purchasing software that's cloud-based or software as a service, that's one way to enable a sort of parity and potential way of future-proofing those investments rather than having to make them at 5-year increments and being constantly out of date.
First part about shelf life, as I explained in my first slide, AES as an owner and operator of power systems, and for the first several years developed this internally to put it in its own assets, connected to its own assets, to solve problems in its own assets. Always designed this in a way that it would last. So it's designed by an owner and operator to be used by an owner and operator. So they're designed for 20 years. It's not exactly the same as our phones that we buy, and after a few years we're complaining that the battery doesn't last. It doesn't work that way. And on the second part, I mean, should we wait? It's the matter of it's already real and developed enough that it's more economic than the alternative. There will be no reason to wait. If it's already more economic, it's already better. It already does more.
Yeah, and it brings up an interesting point that I think Dr. Taft raised this morning about, hanging up the window without doing the groundwork. And so I think that's something that we're going to have to deal with and contend with is what do we create from this, and necessarily are the windows that get hung up, are we going to be sort of in that space, or we allow for you to be in that space, and the technology will then develop from there. But clearly there'll be at least a baseline. I think Tom's question that he asks is a really good question, and something that we've had to deal with actually here at the commission, and even sort of the baseline tech that is deployed to advance the customer experience. We got to make sure that it's the right baseline tech. Commissioner.
Yeah, gentlemen, thanks very much. 2 quick questions. Ty, there's a growing general appreciation for the value of information consumption data in the industry. I've seen interval usage data being shared, either aggregated or anonymized or both. But can you give an example of any disaggregated data that has been supplied to third-party providers, for instance?
So this is the more granular than
Yes.
hourly data?
Yeah.
So in general, no, and I think that's one of the challenges is that from a being able to pull it back through a telecommunications pipe and store it in a database. We've seen at some reasonable scale, tens of thousands, hundreds of thousands of points, 5-minute data, but really nothing below that. It's just not effective to really take that out of the device that's actually measuring it and storing it and sending it somewhere else. So this is really a new frontier in a lot of cases, and this is where, and this is Itron's sort of our approach to the innovation in this space is to, instead of looking at let's take this data out and share it around, is let's keep it where it is and perform the analysis more locally, where it's appropriate, where it makes sense, where looking at this highly granular information creates value for you, provides you measurements and indicates interesting things or important or dangerous things that may be happening locally. Let's take action as soon as we can with that information as it's stored. We've seen, and we've talked to some of our utility customers about taking sort of little snapshots of that, so 5 seconds worth of data or 10, 15 seconds worth of data when something interesting occurs, and shipping that to back office for sharing or looking at or analysis, but really nothing more than hourly load profiling as far as sharing goes.
Okay, thank you. And Pablo, actually it's a follow-up to Commissioner Trumbull's question. I take it from your response, there's no example you can provide us of a third-party community solar development project that integrates the use of battery storage as well?
Can you?
Yeah, I'm sorry.
You mean an off-grid?
Yeah.
There is a, yes, if you consider islands off-grid.
Yeah.
Yes, there are examples
Okay.
around the world of energy storage being deployed with solar, especially. Even AES has also a contract with Kauai, was selected on a PPA to put energy storage and solar together. So 28 megawatts solar and 20 megawatts energy storage, and headlines call it as dispatchable solar.
Yeah.
But again, we see it as a possibility, but very specific. Not very specific, but specific to some places, some requirements.
Right.
But yes, there is so many we couldn't cover today. But there's so many applications, some other applications that we have already in the field that we didn't talk today because I thought it was less interesting than the other ones, the newer ones. But no, especially for this commission. But they're very, very much a very broad range of applications that you can use energy storage economically.
Okay, great. Thank you.
Mr. Conway.
Thank you. For Ty and Brian, your firms provide products, services that take advantage of, leverage the existing investment in the AMI, correct?
That's right.
And one of the blessings or virtues of it is that the incremental cost of doing so is very low since the investment has already been made and is not otherwise being used. Do you think that there's any reciprocal obligation since the products and services gain the advantage of that investment to produce value? Is there any reciprocal obligation you think that there is for what you do, what your firms do, ultimately to help defray the cost of that initial investment?
I'll speak to that first, sure. Well, of course, every utility we work with has a different business case that's driving their investment in working with FirstFuel. And there are many ways that they derive value from our product. It could be reducing customer service costs. It could be more cost effectively reaching their energy efficiency goals, or any number of other drivers. And so we don't dictate what that business case will be, but we certainly have a good sense of where the value may be. And that's inherent in every investment that any utility makes in our system. The other thing is there's an opportunity cost. As I mentioned, there's this sort of build it versus buy it decision that any utility will go through. And there are many talented people in the IT departments at utilities that have very difficult problems that they're handling. If this is one that can be taken off their hands and it is proven to work with customers and has good results, that's able to put those folks toward more difficult engineering problems that are going to be potentially higher value. So all of that goes into the business case, but it's different from utility to utility.
Yeah, and I'd say we absolutely, as Itron being a big part of the a supplier of products and services when you're putting in an AMI solution in the first place, we're always extremely cognizant of the business case that the partner utility needs to achieve, and we've been very successful in helping them achieve or better their milestones. I'd say that even better is we are absolutely incented ourselves to create more value off of those assets that we're putting in, because we're making an investment, the utility's making an investment to create and install and deploy that solution. It's a lot of work, it's a lot of effort, it's creating a lot of useful value and a lot of potential value, which we certainly hope to help harvest. So our objective, especially with our corporate strategy of providing systems that are multi-use, multi-service networks that have the ability to deploy applications in a distributed fashion, is that there will be different and new values that the utility can harvest after the fact. That's only going to improve their overall. It's really going to be benefit on top of their original business case that they're putting in the first place. So that's really our reason for being and our corporate objective at large.
Let me just ask one more follow-up question. Are there any examples where the utilities that you work with charge you a fee or require you to pay for access to the AMI for your purposes?
Not that I can think of. Usually we're being paid for providing the analytics service rather than the other way around. I know there have been questions about data access and who's able to see what kinds of data, and different jurisdictions have handled that in different ways. We've facilitated transfers of data to other providers through Green Button Connect. That's never disaggregated data, to your earlier question, Commissioner. It's simply the meter data in a XML format that is machine readable, and that is usually required by a commission as the format of choice. It's a DOE and NIST supported format. But we're not charging for that service to whoever's getting the data. I know that there are other commissions considering that as a model, so it's certainly something that's out there for consideration, charging for the data access, but it's not something we've encountered.
Yeah, I'd say that providing data access or using the same infrastructure that's been leveraged or that's been put in for an AMI solution, for example, Itron is usually not a supplier of a different service. We're helping put in that platform to begin with, but we certainly do work with utilities who have a model of beyond the business application that the AMI network was intended for. If it's able to provide additional services for third parties outside of the utility, we've worked with utilities in creating business models to help them achieve that, where they're absolutely going to be charging for access, use of the network, use of the data from the individual devices, whether they decide that they're going to do this as only as a benefit to the consumer, or if it's a service that they will charge to a third party who's getting some benefit on top of that. That's absolutely a model that we've explored and worked with a number of our utilities partners to explore.
I don't want you to read anything into the question. I didn't mean it as indicating what position I or anyone else might take on it. It's just I can see it,
Yeah.
an argument going both ways, actually, that it's opportunities that are lost if you don't take advantage of them, or if they are taking advantage of them, maybe there should be some sharing of the initial burden for the platform that allows the opportunities. So thank you very much.
Thank you. Questions from the staff? Down here. Okay, let me go down here first. Christina? No? Patrick? Go ahead.
And okay, that did turn on. Again, thank you. And I think this plays off of the other questions that the commissioners were asking is, do you have a position on who should own the data and have access to the data that is being created?
Yeah, so I think this is pretty consistent the world over. Is the data is owned by the consumer because it's related to their habits, their usage in the home, and I think it has to be treated with that consideration. There's a level of privacy and security that goes hand in hand with that. So most of the services that we've talked about and have seen implemented. Beyond those used to invoice the customer and provide benefit from a grid stability and reliability perspective, require some sort of opt-in from the customer itself. So I think that's been universal. It's the end consumer's data at the end of the day.
Great.
Yeah, I think it is consumer data. It's consumer data that is used for traditional business purposes in the utility sector. So if you were to identify what those are, perhaps broaden them, I think that's a consideration every commission takes into account. Obviously, there are things like billing or reliability where it is very clear that that is a necessary use of that data. But you're asking a perfect question, which is, what are the additional uses and how can they be defined as, consumer-owned or utility-owned? I wouldn't say we take a strong position either way. We're mainly focused on ensuring the security of that data and that it is only passed to third parties or other providers when the customer has created their consent and authorized that.
Very good. Mahila.
This is a question for Pablo. Pablo, now a 10 megawatt energy storage facility can be ramped up to 10 megawatts instantaneously, and it can also be discharged to negative 10 instantaneously. Am I right?
Yes.
Okay.
Not negative, but it charges, it ramps. Your question is about if you need 10 megawatts of power,
Yeah.
how long does it take if it's sitting idle? How long does it take to discharge those 10 megawatts of power?
Yes.
It's sub-second.
Okay.
It's milliseconds.
So,
it ramps up. That's the whole flexibility. It's always synchronized. It's always online.
Okay.
And it can do it autonomously, responding to something it senses on the
Okay.
grid, or it can do it by following a signal, or it can be even dispatched manually.
Okay. So during your capacity negotiations, are you offering up double the capacity, as in a 10 megawatt facility? Are you offering up 20 megawatts because of this ability to discharge as well as charge instantaneously?
It's the flexibility that you have and range that you can operate.
Okay.
So if you compare 100 megawatts thermal peaker with 100 megawatts energy storage, 100 megawatts thermal peaker has to be operated at its minimum level around 40 megawatts maybe, 20 megawatts maybe. And then it's going to be a much smaller range that it can go up and down depending on what the grid needs.
Okay.
And the energy storage, you can charge 100 megawatts, then discharge 100 megawatts for that time period, that of duration of those batteries.
I think really what I'm wondering is what would be the nameplate capacity of the storage? Would it be 10 megawatts or would it be the double?
It's a good question. Energy storage it's so different. So we have people saying, respected people saying that energy storage could be, because it operates in transmission, distribution, and generation, and it has applications on all those three. It could even be at some point it's a fourth one, and you can say, well, and then there's a storage, because it does something so unique and so different and so valuable. But we, because we have a great respect for the grid that we have because the lights are on and it works well. We always try to adapt when, like I said, on negotiations or on biddings. We always try to adapt to the rules in place, to how this is evaluated, and then we push for the flexibility to be evaluated as well. But I would say yes, the nameplate capacity would be 100 megawatts, because that's, if it's fully charged, that's what you can discharge for that duration. But we see that something much more, it's a concept that would have to evolve at some point, depending on which perspective you're asking that question.
Very good.
Thank you.
Okay. Tim, we're good? Okay, very good. Round of applause for this panel, please. Thank you. Thank you so much for your participation today. Again, commission meeting, public hearing, or typical weekly public hearing, 1 o'clock, and then we'll reconvene Power Forward at 1:15. Thank you very much.